Let's give everyone just a few moments to get their notifications and then drop on in. Welcome, viewers. Dropping like stones. Okay, we've given it enough time. Well, let's get this show on the road. Greetings, Houdini fans from around the world. It is 3 o'clock and it is Friday, which means it is time for another episode of Houdini Secrets Live. My name is Chris and I will be your host for today. Now, as you know, we've been dealing with Houdini Dynamics pretty much from the ground up. And the last couple weeks we've been going on how to get all these dynamics. Once you've created a groovy simulation, how do you get the dynamics into UE4? And you typically use VAT, but the process of using VAT is a little bit laborious and prone to error. So what we did last week and the week before was work on a script inside UE4 to bring in VAT data and have it processed to kind of take away a little bit of the guesswork. Now we've got most of the way there, not 100%, because I did find out that at this moment in time there is no way of modifying via script the world position offset or custom UVs via Python. Just doesn't exist right now. So far, no one knows about anything. So it's evidently not on the Epic side effects, the Epic's to-do list, but maybe it'll be changed in the near future. But in the meantime, what we're going to do is we're going to return back to our origins, and I myself have been going through this course offered by John Moncrief over at Side Effects about the foundations of collisions. And I'm actually finding this course extraordinarily helpful. It's a very, very convenient course, and it's a very extensive course. And what I'm going to do is I'm going to kind of give it to you in kind of a short form and kind of give you the Cliff Notes version of what this form is, because I find it very informative, not only because it shows the essential behavior of how collisions work inside Houdini, but really at the core how DOPS works at its fundamental core level. And I'm finding this very interesting because it's really getting deep, and I'm starting to learn gobs amount, and I want to share what I learned with you folks here. And so without further ado, let's get things going on with our dynamics demonstration and focusing on collisions. All right, here we are in Houdini. Now, typically when we set up a collision, let's go ahead and throw in our Roberto. Come on. Daggone it. Is it going to be one of those days? Yeah, I think so. All right, test geometry. When all else fails, do it the hardcore way. Replace that. We have Roberto, and we're going to move the camera up a little bit, and we're going to move Roberto up a little bit in Y, and we're going to offset him a little bit this way, a little bit this way, and just a little bit of pitch. There we go. Okay, Roberto's facing us in camera. He's there with us in spirit, so he is groovy and good to go. Now, typically what we would do in a typical DOPS environment is we would go on over to our rigid bodies section, and we want good old Roberto here to be an RBD hero object. So I'm just going to press my RBD hero object icon. We're going to select Roberto, and it turns him into a rigid body object, which is now gone inside. It has a DOP network. Now, if we go ahead and hit play, Roberto falls like a stone, which in fact he essentially is. So let's take a look at what Roberto has done here. What they did was they hooked up, they've got Roberto, they put in a REST SOP here, and then use something called a DOP import. Now, a DOP import is a very primitive little interface. It's kind of a transportation mechanism. What it does is it transports the data from the source and then sends it to a DOP network and then brings in that data again. So let's take a look at the DOP network. Here we have Roberto, and you'll see that it has a reference to the DOP import SOP that it starts with. This merge, well, this is not really necessary because we're just keeping one object, so I'll put that here. My rigid body solver, this is the solver that is done to solve the rigid body network. And then we got to get rid of that. We'll get rid of this merge. And then we have gravity, because gravity is the only force acting on everything, regardless of the dynamics that happen. So gravity happens last because gravity is always going to perform. And this actually kicks this out, and believe it or not, the DOP import SOP back on Roberto brings it back in and it sets it going. Okay, so now let's go back up here and let's create ourselves a ground plane. And we would just typically go around here and come over here to collisions, and we would just hit the ground plane, and then we see this ground plane come in. And now we know that this ground plane is sitting at the origin, but it actually goes much deeper than that. And even though we only see portions of it, it looks like to be about 1, 2, 3, 4, 5, 6, 7, 8, 9. It's about 10 by 10 essentially. It's about a 10 by 10 grid, but it actually goes on infinitely. And that is of design, and I'm going to explain into that later. But when we go ahead and hit play, Roberto falls. God, this is so undramatic. We got to get some kind of dramatic behavior from Roberto. Come on, bud. We want you to be form here. Put you up a little bit higher, at least, getting a little bit of velocity. Yeah, geez, that's pathetic. Oh well. Roberto doesn't want to perform today. Let's see if we can give him just a little bit more of a nosedive. Come on back over. He's doing a header. Just like he's been skating on a skateboard ramp and suddenly he ejects. And boom. Comes crashing off the ramp. All right, great. Now let's take a look at the ground plane, our DOP network. Now the DOP network basically added this information onto our DOP network. Here we have our ground plane object, which is pointing towards our /obj, our ground plane object, and there's the color and then the grid size, so it's 20 by 20, and there is its initial state and its physical properties, and that's all good and fine. Now this merge, not necessary. Now this is another solver inside of the DOP networks. This is a static solver. This is a solver that handles all the static objects within the scene at a given time. But since our ground plane is the only one going on there, that's all that's necessary. And Houdini had put this on after gravity, but honestly, I happen to know that if you wanted to go ahead and shake this bugger off and put this in here, and if we wanted to go ahead and knock that off here and put this in here, and we'll switch the order. It is important, the order, because remember, the solvers work from left to right. And so, yeah, I did have to change the order on that. Now, if I go ahead and play this, we still get the same situation, the same information, regardless. I like putting gravity at the last. It kind of like gives me some kind of resolution. So let's go ahead and take a look at our auto DOP, or our ground plane object here. All right, so we click on here, it's a ground plane, and it's an object merge. And look at here, it is got a reference back to the auto DOP network and a ground plane 1 display. And so that's kind of nutty. So it's kind of like a reference back to the auto DOP network, which originally called it. So if we go to the view and then we show all dependency links for all nodes. Whoa. Okay, look at this, gang. Let me go for just a view for the selected nodes. This is too much. So for here, look at here. Well, it looks like we've got a figure eight. It means we have a kind of like an infinite loop here going on here. And this is, could be powerful, but evidently this loop definitely works. So let's go along with it and not try to fight with it, because it seems like we have a infinite loop. So let's go ahead and go into, I'm going to turn off my ground plane object just because I just don't want to see it at the moment. So let's go into our AutoDOP network, and now we see it again. And so let's go into our ground plane. Now look at this. The ground plane is actually a digital asset. And so what I'm going to do is I'm going to open up, or to make it allow the editing of contents. And so we're going to go and bust into our ground plane. And you'll see that it is a virtual display of a cornucopia of information, which is actually kind of important. And notice here that here is the a new SOP network. If we go inside the SOP network, then we see this is the information for our box. This is our visual display of our box. And so this is where we get the definition of this little kind of ground plane here. So this is actually pretty cool. And so what's in here with the collision? All right, this is actually just a basic grid, a 2020 by grid all by itself, and it has an attribute, and it's got a no point volume and no edge volume attributes. We'll probably encounter what those deal with later. And then it just simply goes out to a null. Okay, but then this collision is being referenced all the way over here at the geometry. Okay, now here is now let's take a look at the nodes that are in here inside of the network. Now it seems like we have a loop, but the object path here seems to be having a loop to the SOP definition. So it goes to the SOP, and the SOP is referencing back into here, which is actually kind of nutty, because what we're doing is we're only grabbing the position and the orientation from the SOP network. Now, if we were to delete this object path right from here, we'd still see it, but then if we come up here, we've lost the control here. And if we display this, it's still there. And will it still work? Yeah, it still works. And so really that double path was really just a reference to the visualization, the position and the orientation of that ground plane. But the ground plane itself is infinite. So that's really only done for visual purposes itself and is not really necessary. So good to know. So let's take a look at what each of these things are. So let's go into the ground plane, and let's take a look at each of these objects. Now the empty object here is geometry used for the node, and that means it goes, all of the nodes are applied to the object, to the applied data node. And so you need to have an empty object to store everything. So basically this is a bunch of information. What kind of information? Glad you asked. So let's go ahead and add our inspector, a geometry spreadsheet, and then suddenly this takes on a whole new life. Now when we go into here, we see the geometry, but it takes on a whole bunch of new information here. And notice here this empty object is really just the very, very basics here. And this is showing not just this node, but it's showing the entire state of the network at that point, at this position. And so if we click here, we really just have the basics. We only have but when we go here to apply data, then we go in here and this opens wide up, and then we've got just a buttload of information here. And this is where all of the magic happens. And so really, when you're working with DOP networks, you're really just applying a very vast amount of information here. And there is all the tactical information for Roberto. This is all for the relationships, and this is all for the tactical informations for the ground plane. And we're going to be focusing primarily on how to set this up in order for the ground plane. Now, I know that we're basically reconstructing what's already been done for the ground plane, but this is really the key to all collisions, because this is the prototype of side effects telling you how side effects wants you to go and construct your own collisions, which is actually pretty good. And so we have this applied data, and this is all the stuff that gets put into right in here. You'll notice that you'll see some kind of information. You'll see that this here, the SOP geo, this has a little geometry next to it. And this one has a little thing called position, so this is going to correspond to the position there. This object here is going to also correspond to position. Here's some physical parm. And so let's take a look at what each of these are individually. And, oh yeah, render parms. Okay, render parms is for renderings and storing kind of the information. And notice that the data name goes under render parms. So the render parms gets put not under here, but it gets put under here where it says SOP geo. Now the SOP geo is the data name, so it's called display geometry. So I'm going to go over here to display geometry, and we come over here, and there's render parms, which is a child of our display geometry. So our render parameters is just storing a bunch of parameters to show how we're going to render our collision geometry. Well, we're not really going to spend too much time rendering into it, so we're not going to really muck around with the data here. But this shows you how to create hierarchy inside of the database. Now here, collider label. Now this creates a folder inside of the database, and this is called colliders. And colliders, there it is. It's sitting right here, and it's got a bunch of information. Now it tells the DOPS environment what kind of finder or what kind of collider this is actually creating. If we look over here into the little pull down there, we see all the various types. You can have a default, a particle, a wire, a cloth, volume, a thin plate, a packed object. So all these can be potential colliders. And this is the kind of like the enum that tells the DOP network what to look for. Okay, then we go to our link to source object, and this creates, it's a reference to the OBJ path. And so if we click on here, we say it's the chop, it's the object path. So basically this is just a link to the object path that we created up here. So here's our object path, and right now there's nothing in it. So let's go ahead and put that information back in. Yeah, we still have it. All right. And now back into here, we see that this value now reports that. So this is putting that information into DOPS, and it shows us where the source object is coming from. Now in this case, we're not going to use it, but just to let you know that it is there. Now here is an important node, bullet data. Now the bullet data is needed for the bullet solver, and the bullet solver is a type of rigid body dynamics solver. Now there are multiple rigid body dynamics solvers out there, and bullet just happens to be the one that Side Effects uses in its RBDs. And it is necessary, and this bullet data provides all the necessary data in order to configure the bullet engine. And like I said, the bullet engine can be found in other softwares, and it is an open source. I believe it's open source. I could be wrong. But notice here that it is put under the geometry and bullet data. So here we have the geometry. And geometry has got a bunch of stuff, including the render parms. But here is the bullet data. And so all this information for the bullet data goes right here. Now whereas, okay, we've got our SOP geo. And our SOP geo creates a bunch of information about the geometry network. And so it really is it's creating a new folder here. It created this geometry folder, and it has a couple of children for it, and it tells it that it wants a volume and some render params, and so these all get put into the geometry, and so now it goes. Now, could we have put the bullet data into the geometry? And if we wanted to, we could have gone ahead and put the bullet data and right up into there, and it would have been basically the same thing, because the bullet data is, you'll notice that it's still here in the geometry, and everything is still going. Oh, let me go ahead and sever that. And everything works accordingly if we were to go ahead and run Roberto. And ooh, interesting. So it doesn't work. Okay, so it does say we have a warning here. And what is that warning? It says this data is attached to unexpected parent data. So what I'm going to do is I'm just going to return this back to whence it came. And now everything is hooked up nicely, and so it's now working. So interesting, even though it is a child of the geometry, it has to be hooked up in a certain way. And we'll look into that way that it's hooked up a little bit later. And now for our render params, we're going to display, we're going to look under here, and we're going to express how to render what's called an implicit plane. Now we've set this volume to say that it is an implicit plane, meaning that our plane or our collision volume goes on to infinity. So it's infinitely large. But how do you render that? Well, that information is shown right here with this. But notice here that the display flag and the render flag are both turned off. So therefore, we're not going to see it whatever. So that is good to know and good to deal with if it happens. Okay, what other data is there? We've got a switch node that goes into a switch if the object path is parameterized. If there is no, look up here in the switch node. If the switch node is basically, if there's nothing in the switch node, then go ahead and use this motion. But if there is, use this one for the object path. And it's just a reference to the ground plane object yet once again. All right, so this brings us back in. So the takeaway from all this is that this ground plane object isn't actually modifying the empty object. What it's doing is it's actually attaching data to the empty object, and it's going to be solved and used at a future time during the solve process. So technically, this ground plane object, all it's doing is creating a configuration for a ground plane. And so that's really all that it's doing. All right, in order to really demonstrate what's going on and to really test this, what we're going to do is we're going to go into this system and we're going to create our brand new custom-made ground plane collider. And I am going to turn off my dependencies. Come on. Hello. Hide. Okay. And we're going to go ahead and get rid of all that and get rid of our DOP network and our ground plane object. And so we are going to get rid of those. Okay, and so we're going to create this here. All right, so we've got Roberto, and I'm going to go click on here, and I am going to go and make Roberto a RBD hero object again. And so what that's going to do is going to set things up. Come on. Oh, there we go. And then we're going to add just another ground plane. Collisions, ground plane. And then we're going to hit play. And everything is working as expected. Okay, so let's drop inside of our DOP network. And we're going to get rid of the extra merges. Going to get rid of that one, and there we go. And we're going to sever the ground plane node. We're going to go ahead and kill this. All right. Now, we're immediately going to get errors, but that's okay because we're going to go and undo those errors. So we're going to build a brand new ground plane object from the ground up. Haha. How's that for a play on words? All right, we're going to lay down, we're going to start with an empty object. So we're going to go ahead and click on here. We're going to add an empty object, which is a DOP. And this is the beginning, and this creates the foundation for our network. And I'm going to call this my ground. And so for the activation, I'm going, it says ST equals 0. Just going to go ahead and delete that and put that at 0. Okay, so that means it is not activated. Now let's go ahead and take a look at this. Now notice that there's nothing in here. When we press ground plane, we got nothing in here. Now if we go and hit output, that is a whole bunch of stuff. We have a broken system, so basically we don't have anything on here. Now if we wanted to go ahead and activate our ground plane, we would go ahead and take this to $ST equals 1. And so what that does is it says, okay, we're going to turn this on for the simulation time. And, oh, I'm sorry. Let me go ahead and turn this off and keep this a little bit primitive. I'll just go ahead and turn this on. Now notice here, when we play one play, if we go ahead and move this forward, okay, and the number of objects, okay, all right, so let's go ahead and we move that. Okay, so let's see, I think what we have to do is hook up our ground plane to the static solver. Is that going to get things going? Aha. Okay. Yep. Okay, we move that over here, and we have Roberto and object 0. Object name, and it's called like object 0. So let's go ahead and let's change the names to my ground. Okay, so there it is, my ground. Okay, there's all of our stuff. Now, since the activation is 1, if we go ahead and put that onto 2, we notice that we get another my ground. 3, 4. Okay, so for every frame, it's going to be creating a brand new collision object. We only want one collision object, and that's the basic. So we want, that's why we put ST equals 0 here, $ST equals 0. And what that does is it guarantees that only one's going to get created at the 0th time. So notice now that we play it, we don't have any kind of nothing afterwards. So that's exactly what we want. Okay, so now we know we're going to be collecting data. So we're going to drop down here. Now we've got this. When we have to, this is this empty object. It's not ready to actually start colliding with things yet. And so what we have to do is we have to get it. If we were to go ahead and play this, Roberto's going to pass right on through. Okay, so we got to configure our ground object in order to get it to work up right. So I'm going to go ahead and hook up and apply data. And hook that in there. And so we have the foundation here. Now all of our data is going to get hooked up into there in order to configure it already. And so the first thing I'm going to do is put down a position DOP. Okay, the position DOP is going to establish the position of our collision area to the DOP network. And so we're going to drop that right into here, into the apply data. And so now let's go ahead and put in some kind of position for it at 1, 2, or 3. And if we look over here at the geometry specialization, we now look over here my ground, and it does have a new positions information. If we click onto here, we see that the translation or the position of this object is 1, 2, 3. Okay, so it is there and it is working properly. All right, so let's go ahead. I'm going to return that back to 0. Okay, and now we've got the position now. Well, let's go ahead and grab some geometry. And I'm going to grab a SOP geometry DOP. SOP geometry. All right. And I'm going to plug that into here. And so here's our SOP geometry. And it is, we've got that. And here we go. And we're going to leave everything kind of like by default on this. And now remember, we referenced a plane inside of our, we referenced an object outside of ourselves. We referenced the actual ground plane itself and bring it back in. But we're going to do things a little bit different. We're actually going to do it within the context of this node itself. So I'm going to double click into here, and you'll notice that it goes into a geometry network. And use, okay, but before we go do this, if we look over here and we have to say use external SOP. So that means we're going to have to use some kind of reference on here, but before we do that, we're going to have to turn that off. Say now we're going to define our SOP network in here. Now I'm just going to add just a grid SOP. You know, exactly like our collision volume that we had before. And then I'm just going to leave it as is, sitting right at the origin, 10 by 10. And we're going to append a null SOP for general. All right, so it is good to go. And I'm going to put the display on true. If we come up here, and we are good. Okay, so what we have is we need a little bit more data here. And now let's see, it's giving us a warning. It says cannot find SOP. Okay. Use external dot path primitive group. Okay, so I have a hunch that this is because it can't find the SOP and it's not there. But needless to say, we told it not to use one, so we got it there, and so there, we got rid of that. All right, very good. So let's go add some more data. Okay, so we're going to add a collider label because we're going to tell it what kind of collider we're going to create. So let's drop down a collider label. There we go. Now drop that right into there. And now you'll notice that where it says the final label, instead of none, we're going to change that back to volume because we want this to be an implicit geometry. Immediately it goes on infinitely. Now notice that this is the data name is called colliders, and so therefore we have a collider information, and it stores all of our and it tells us like, what kind of label is it? It's a volume. So this is really kind of an elaborate enum. Okay, and so what we have here, this collider and using this volume is kind of nice for the bullet solver. Now, the bullet solver likes this kind of stuff. And so this is why we're setting it up this way. Now we could set it up any way we want. If we wanted to use this as the old RBD solver that used to be, well, that still is in Houdini, but if we wanted to use the old one, we could still do that, and it would be just a little bit different. But I'm going to focus on the bullet solver for this moment in time. Now, speaking of bullet solvers, all right, so let's go ahead and add a rigid body solver. Okay, so what we have here would probably work. So let's see if we've got this. Actually, we should be good to go. This is good for we are set up. But right now, even though we're kind of configured, or eventually we're going to use this for a bullet solver, but we still haven't established it as a bullet solver. So by default, it thinks it is a rigid body solver. So let's go back up to this level, oops, and go into the rigid body solver here. And tell this, instead of using a solver engine, let's use the old rigid body. And so if we did everything correct, now you'll see this is how we got things configured up. If we go ahead and hit play, and it is working. Now, be it as may, it looks a little bit funky, but that's because we're not using the bullet solver, which is a better solver than the RBD engine, but it is ultimately doing the correct information. We haven't really quite established how to create all the full-blown collisions yet. All right, now if we go ahead and turn this back to the bullet, we go ahead and we click onto here, and it does not work. It's because we don't have a bullet solver. Actually, we have a bullet definition hooked up into there. So let's go ahead and solve that. Let's go and add a bullet data. All right, we've got a bullet data. Now notice that this goes under the geometry node, under the bullet data information. And we hook that right up into there. Now when we hit play, well, we got the good collision. All right, very, very good. So this is not, but ultimately, if you are working on Houdini 18.5 earlier than 4.8.6, the collision is not going to happen in the right place. And so if this does happen and you're using an older version, then what you're going to do is remove the position. Now this is a bug that's been recently fixed, so it works just fine on my machine because I'm working from 5.3.2 at this moment. But what we would do is remove the position and then drop down a motion dop. Now remember our, oops, come on. Now remember, on our last network, by default, there is a motion dop for our for the default ground plane, but we chose not to use this. But in order to get around this error, then you would add a motion dop, and then we would say the position equals 0, -1, 0, and put that into the apply data, and so it stacks it up in there. And actually, the motion dop is more compatible with the bullet data. So if we wanted to go ahead and click that, and so it notices that it breaks it a little bit low. So let's change that to 0 and try that, and it works just fine. So you could either use the position or the motion. Now, once again, the position is pretty good for RBD. Motion is pretty good for bullet data. And I'm going to go in and I'm going to sever this, and I'm going to put the position back into there. And just has to make sure it works. All of it works. All right. Now we have to give the geometry a little bit of definition. So we're going to drop down, and now remember, this isn't. This will only work for the position of the grid that we've got here. This isn't infinite. Let's see. If we were to go and move this of the position to someplace over there. Now if we go ahead and hit play, that's right, folks, it falls in. So we don't have an infinite plane yet. So what we're going to do, I'm going to move that back to 0, and so now we have that, but now we've got to transform this physical plane of what we see as a visual. We actually have to turn that into a implicit plane, or otherwise an infinite. So I'm going to drop down an SDF representation. Now, if you remember, a handful of a handful of lectures ago, I actually did display what SDF stands for. It means a signed distance field. So that means we're creating a volume that creates a signed distance field. And a signed distance field is kind of a primitive volume representation. It's a little bit like ray tracing. And so the signed distance field tells a relative position of one object into another. And the signed distance field just basically responds, hey, is this point inside the volume, outside the volume, or is it sitting on the edge here? But for this mode, we're not going to worry about as a ray intersect, because what we want this to behave as an implicit plane, meaning goes on forever. Okay, so we've got that, and we're going to hook that into our applied data. And so now this is our volumetric representation of the SOP geo network. Okay, and so now if we were to go ahead and modify the position onto here and move this off to someplace else and hit play, we still have that. And so there we go. We'll put that back, and we have the collision actually behaving as exact. Okay, so what we need to do now is to complement our volume. We have our volume here, and a volume here goes underneath our volume. All right, and so what we're going to do now is, let's see, the volume, does this need to be under our volume? This volume goes under this, and I wonder if the volume needs to be under geometry or not. That's a good question. I'll have to get back to you on that. But the last one we want to adjust here is put in a rendering parameters volatile. Rendering parameters volatile. Okay. And so we're going to top that into the applied data. And now for this, we're going to say 1. This will turn the display on and off. And for the render, we're going to do it by 0. Okay, so in other words, we don't really care what this deals with now. And so let's go ahead and check this out. Okay, so there we have is our collision plane. All right, and so now what we have is our very own custom collision plane. And I'm going to go ahead and get rid of all this. And I'm going to clean things up a little bit. And let's see, can we turn this into a subnetwork? And I'm going to call this custom ground. Okay. And we say we don't need this one anymore because it's all implicitly. Now if we go ahead and display this, it should automatically collide with the ground plane automatically. All right, cool. All right, well that is really all that I wanted to go over right now for the collision planes, because honestly that's all that I've studied with John Moncrief's class. And so that is going to be all we have for now. Now let's see, let me go ahead and bring this little up. All right, so we have, here we go. Oh, the lecture. No, that's not what I wanted. Yeah, there we go. Tune in again in 2 weeks, or in 3 weeks. Now, I do have to say this is going to be 3 weeks because I'm going to be out of town for the next couple weeks on Friday. Yeah, you named it. Yeah, my wife is taking me rock climbing, so I've got to do what it takes to maintain the domestic tranquility. I have to keep the wifey happy, and that means I'm going to be taking rock climbing for the next couple of weeks. So on Fridays, I'll be rock climbing. But anyway, tune in again on 6/11. That's in 3 weeks. And so that will be dealing with the collisions part 2. And so what we're going to do then is going to give me a little bit more time to go through John's course and kind of transcribe the data for you folks. And what I'm going to do is kind of like figure out if a little bit more detail if we wanted to really create our own custom collisions, what it take. So I'm learning along with you folks, and I'm actually having a great old time because this is giving me a really robust understanding how DOPS actually thinks and behaves. And this is very helpful, at least understanding things and understanding Houdini dynamics on a more holistic level. All right, so check us out. If you have an opportunity, if you're a Houdini fan, check out OHUG number 8. That means next Wednesday, next week, 5/26, the 26th of May, 12 p.m. Eastern Standard Time. Now we're in Orlando, and so this is in Eastern Time. Check us out here. Simon Verstraete will be live from Ghent, Belgium. He is going to be presenting to the OHUG, and he's going to give a basic fundamental description on world creation using Houdini. Now, if you haven't had a chance to check out Simon's stuff, go check it out. It is great. Go to the Side Effects website. He's got a dozen, or at least, of great tutorials. And if you check out his stuff on ArtStation, it is really fantastic. His stuff is really amazing, and we're honored to have Simon come and present to our Orlando Houdini users group. So if you want to come and join us, please go check out the meetup.org or meetup.org for the Orlando Houdini users group, and come on, check it out. And you'll see it online, and come and join us. We'd love to have you. And this is all one big old merry party. So of course, if you don't belong to the OHUG, that's fine. Just come on, sign up, and I'll give you the link for the Zoom, and you can come and join us. So it'll be very, very exciting. Okay, what he's going to do is he's going to be going over creating terrain, asset placement, cities, and he's going to go over how this all integrates with the Houdini engine. So really, really, really valuable stuff. Okay, folks. If you like what you saw today, or if you have any more questions, go ahead and subscribe and reply to this YouTube posting for this class, and check it out on in YouTube. Subscribe to YouTube. You'll get informed whenever we create a brand new episode. Or otherwise, check me out. I'm Chris Rhoda. Check me out on Facebook and on LinkedIn, or go check out Art EDU, and that's also on Facebook and on LinkedIn. And if you really want to join up, if you really dig on this Tech Art EDU jazz, go to the techartedu.com website. Yeah. And go ahead and opt in and give us the information so that we can send you a personalized message about what our latest articles are. And so you'll get informed with all the big updates. Yeah, I know we haven't sent out any messages lately. In fact, it's been a few months. And that's just because all of my free time has pretty much been devoted towards getting in and finishing up the visual effects for technical artists book. We're almost done. We're done with the texts. I've got a handful of artists. Thank you, artists, for coming to help finish my images with me. We've got a good crew going, and we're going to end up with some really looking images. So look forward to seeing that coming at you towards the end of the year. And we're very excited. Go ahead, anyway, sign that up, and you'll get information all about that and all the other goodies that are coming your way. We've got lots of great stuff coming at your way. So thank you very much for joining me today. I look forward to joining you again in 3 weeks, where we go in and into further depths and go into the collisions inside of the Houdini Dynamics networks. And until then, 3 weeks from now on 6/11, I'll see you later. Arrivederci.